going to have on Revit to be able to use Python as a software development language, and sort of like more like an exploration of the APIs and what the possibilities are, and kind of figure out what kind of tools you can create for yourself. So all of you are, I'm assuming all of you are familiar with Revit Python shell. I'm actually going to launch it from here. There's this great project that
are you supposed to share your screen?
Am I not sharing my screen? Oh,
no.
I thought I was still sharing. Sorry. There we go. Great. So there's this great project. If you search for Revit Python shell, there's this great project by Darren Thomas that he created this many years ago, and it sort of like gives you this. When you install it, it gives you this add-in for Revit, a couple of buttons that you can actually launch a Python, what we call a REPL, R-E-P-L. Means that it reads your input, it evaluates your input, and it prints the results, and then it loops and does the same thing again. So what you see at the top of this window is the Python REPL. So if I do like 24, it will read, evaluate, and print the result. If I say 24 plus 12, it does the same, right? So this is sort of like a different scripting environment that we generally are used to. We are used to having a code editor like a Visual Studio Code or something like that. That's sort of like a text editor that you edit your code in. You have that kind of an editor at the bottom of this Revit Python shell. This Revit Python shell is a great tool to explore APIs. If you already have it installed, one of the things that I suggest that I sort of like share with everybody is that if you go to GIST, let's say GitHub, GIST, and then actually you want to discover GIST, and then search for my name here, Iran Nejad, and then if you find these GISTs in here, actually click on my name, yeah. There is this sort of like a tiny script that I have that's called RPS_init, and that's Revit Python shell initializer script. Click on that, and then there's a raw button on the right corner. You can right click on this and say save link as, and it will save it as just a Python file wherever you want to save it. This is one of the things that I do the first time I install Revit Python shell on any of my Revit. So I go to configure, do init script, startup script, and provide the path of that init script on the desktop that I just saved to Revit Python shell. So from now on, every time I open the interactive shell, that script gets executed, and it sort of like prepares some of the variables that I kind of need them to be there. So like doc will be the active document. If I do have a series of, let's draw a couple of walls. I select two walls, and I kind of want to explore this, and I come here and open Revit Python shell. Doc is there, but then now you have E1, which is the first element, E2, which is the second element. So I can very easily sort of like start playing this. I want to see like E1, and then you have auto completion, obviously. Look up parameter, let's say unconnected height, and then I can see the parameters there, and then I can see you can go up and down to the previous statements that you wrote. So I can do p equals and then see storage type of this variable, and I can see it's a double. So I can say as double and get the value of the height of that wall that I've selected, right? This is a great exploration tool, and you do have the Revit API docs website by Guy Tallarico and API docs.co by the same person. Two different, this is Revit specific, and you have a series of like Revit versions at the top, and this meant to be sort of like more of a little more complicated documentation for different software. You have Revit as one of the options, and you can go around and choose different things. You can also search for them. So like if you want to say parameter class, I can find the parameter class, what I just used, and I can see under properties, there's one that says storage type, and I can go and check that storage type value and see what other options are available. And what I see, it's not very clear here. Let's use one of the actually maybe material APIs. Material. Maybe material node. Okay, so you can see that the colors of these dots will change. It does, based on what you have selected, it does a little bit of auto comparison between the different Revit versions, right? So if you have an API that's available in 2023 and it's not in 2022, that dot will turn red. The yellow means that there are differences between these APIs. The Revit API docs, I believe, does the same thing. So if you search for something that's, let's say, forge type ID, for example, you can see that 2020 before, they all have a red bar at the bottom. So that means that API is not available on those Revit versions. So when you're writing script, if you're running your scripts for an environment that uses multiple Revit versions, always be careful about, like, if the API is actually available, that function, that type, that kind of stuff that you're using is actually available in that Revit version. So that's a little bit of about what kind of documentation is available for you, and the exploration environment that you can find more about the APIs. There is another project that's actually very helpful. It's called Revit. I forgot the name. Hold on for a second. I'm blanking on the name. Grab that from here. Okay, repo. There we go. Okay, so there's another project that's called Revit Lookup, and you can get the installers for this one as well. And once you install it, it gives you a little bit of an exploration. Let me see if I actually download and install this for 2021, 22. Let's try 2023. And I'm going to download this and hopefully run this. And it would work very easily. That's completely fine. Okay, so I just loaded that, and it's called Revit Lookup. So I can select a few elements and go to Revit Lookup and say like Snoop selection, and then I see these two instances, and I can explore the parameters, all the parameters that the API will sort of like return to you. So you can explore a whole lot of these, and you can double click on any of these and sort of like go deeper and deeper into the values and all that. So this is actually pretty impressive little tool. You can, if you don't have any selection, you can actually like just do the whole database. So it shows you all the stuff that are available in your Revit model. You can't do, as far as I can remember, you can't do any modifications from here. So you can't really delete this element or purging or anything like that from your Revit model. But it's actually a great way to just maybe just even find the element IDs. Sometimes you can use that element ID to delete and get rid of stuff that you don't like. So this is a little bit of about the sort of like the environment that you are in, and you could use these scripts and the documentation and these tools to kind of like explore the APIs that are available. What I'm going to show you is a little bit about Pyrevit and what Pyrevit is. I'm going to go directly into wiki.pyrevitlabs.io, and that's where I've placed the Pyrevit documentation, right? And we're going to talk about what Pyrevit is and all that. If you search for Pyrevit just in your browser, you will find the link to the GitHub repo. So that's probably the first place that you're going to hit. And in the Pyrevit repo, you also have a link on the side to the wiki, right? Most of the stuff that we talk about, you'll find them documented in the wiki too, and I'll point to them. There are two things that you can do with Pyrevit. Pyrevit is a great set of tools for Revit. I'm going to show just this Pyrevit tab. The Pyrevit development is sort of like some of the tools that I have internally for development. But these tools are most of the tools that you see in your Pyrevit deployment on your machine. So if you download Pyrevit from let's say, go to the repo and download the latest version of Pyrevit, once you install it, just like a normal Revit add-in, once you launch your Revit, you'll see all these tools populated in the Pyrevit tab. So you can do two things with it. You can either just use Pyrevit as a great set of tools, and they're all written in Python, or you can actually start developing with Pyrevit. This is what we're going to talk about more today, like how you can actually add commands to the Revit ribbon and create what we call Pyrevit extensions, right? So these are the tools that I've created over time. Most of them have been shared with everybody. But Pyrevit also allows you to create extensions. There's an extension manager window here with a series of extensions that have been created by other people. You can see their names and sort of like their extensions that are actually there. These are the ones that created this set of tools and decided to share them with everybody. You can see the links to the repository, where they are, and all that. And you can install these extensions and all from right here. But let's go and create an extension just for us, and sort of like create a little bit of Python code that we could use and create a tool in Revit. The way Pyrevit works is that I'm going to let's go to desktop. Go to desktop right here, and I'm going to create just a folder. I'm going to call it extensions. Or let's call it Python Cafe. And then I'm going to go inside it, and I'm going to create a new directory, call it Python Cafe. But this time I'm going to put extension at the end of the name of the folder. The way Pyrevit works is that it works based on the directory structure that you have. So you don't have to create complex definitions and ways to explain where things are in where it should be in the Revit tab. So inside of this, I'm going to go create an empty folder again. Call it, let's say, tools. Or actually, let's just call it Python Cafe. So we have the tab name. And this is going to be a .tab extension. So this is the one that creates the Revit tab for us. And as I'm going through this, you might feel like that I'm creating a whole bunch of empty folders. But what we're really doing is defining a structure. We're putting a tab under the extension. And then here I'm going to call it tools. And this is going to be a panel. So that's going to create a panel inside that tab. You can put more panels in here inside that tab, right? And inside of this, I'm going to create another folder. That's going to be our first tool. Call it max height. And it's going to be a push button, right? And all of these bundles, I'll get to how they actually work and all that. This is what we call, in Pyrevit, we call a bundle. Whatever that folder is with that specific sort of like extension at the end of the name. And this is going to be the button that will show up in the Revit UI. What we need for it is an icon. So I'm gonna go steal one of these icons for now. Let's go steal maybe, I don't know, like one of these icons. Okay, so I put a PNG file in here. That's called the icon, and that's it, right? You can put any sort of like image, like choose something that's reasonable size, so it's not too big because it's just meant to be an icon for your tool. And I'm going to put a new file in here, and I call it script.py. And then I'm going to open my VS Code or any other code editor that you have, or text editor. And I'm going to open that script and write print hello Revit. Just a single Python line. And I'm going to Revit now. Go to Pyrevit settings. And the first panel at the bottom, it's sort of like it's always open. And that's the place that you add the folders that your extensions are inside of. So desktop Python Cafe is where I placed my extension. So I'm going to select that folder. So this is the search path basically for Pyrevit to find these extensions. And I'm going to say save settings and reload.
Ethan, I'm sorry to interrupt,
but
some of the students are asking if you could go back a few steps. It's going too fast.
Oh, okay. Sorry. Yeah, Yeah, I do that all the time. Okay, so let's go back really quickly. We created a directory on the desktop. Inside of it, we created another directory that was called, it's just a folder, and it's called a custom, sort of like weird extension at the end of the name, dot extension. And then inside of it, we created another folder with the name that says dot tab. The names these don't have to match. We just decided that, we decided to sort of like match it. What you actually end up seeing is that this is going to be the name of your extension, Python Cafe, the one that's before the extension. The Python Cafe.tab is going to be the name of the tab that actually shows up in Revit. The panel, tools.panel, tools is the name of the panel that's going to show up inside that tab. And the .push button max height is going to be named as a tool. The tool has a PNG for icon that's named icon. So the names here are important. You're going based on conventions, right? So the convention is to name this icon, and Pyrevit will see it as an icon for the tool. And the script is the actual Python code that gets executed whenever you click on that push button. Now, let me go to Revit. We sort of like reloaded it, but I'll show that process to you again. But you can see there's a Python Cafe tab here, and there's a panel that's called Tools, and it's just like any other Revit panel. You can drag and place them on other tabs and all that. And there's a tool with an icon that says max height. If I click on this tool, I'll get an output window that says Hello Revit, right? We'll get to all of this. So the way we added that extension is that under Pyrevit, I go to Settings, and then Custom Extension Directories. You add the path of the directory that you placed all your extensions in. This doesn't mean that there should be only one extension. And if you created different extensions for your environment, you can put all of those inside the same directory or different directories and add all of them in here. And every time from now on, every time Pyrevit loads, if you close Revit, open Revit, all that, you'll see that ribbon right there with all the panels and all this stuff that you have. And Pyrevit has a lot of options in sort of like in terms of how you actually want to organize this, which should come before the other one, how many tools you want to place in a stack and all that. And I'll show a little bit of that to you once we sort of like get past this first attempt. The other thing that I did was that I used Visual Studio Code. You can actually get that for free online. So if you search for VS Code, this is Visual Studio Code editing, and you download that for Windows or Mac or Linux, all same environments, all that. So you only need to learn the environment once. The only thing that we don't necessarily get is the auto completion that we usually get in a tool like Revit Python Shell, right? So it's a little bit harder because you don't get auto completion. You kind of have to go find different things. There are ways to add sort of like a path to what we call stop files, but that's a little bit more complicated to sort of get that set up. But what I generally do is that I come here, if I'm exploring a piece of API, I come here and I start playing with that API and I grab whatever that I created and go into the actual script and start using those methods and functions and stuff like that. So in here, I just place a print hello Revit. Let's get rid of this. Let's do import autodesk.revit.db as db. Most of you have played with Python, a lot of you are used to seeing this from autodesk.revit.db import star. You might have seen this. This is generally not a good habit. What it does is that it brings all the types that are inside of that module into your Python script, and it makes things very complicated. It's better to import it as a name, just like db, and then use what's inside of that db very easy. Let's collect all the walls that we have. Walls equals db. Let's explore this right here so I can actually show you, because I don't have auto completion. I'm going to say db filtered element collector. This is the way you collect elements inside of Revit with the document, and I can see off category of DB, built-in category, because I'm using a built-in category, OSD, walls. I'm going to call 2 elements on it. And I'll give me a list of all the walls that I kind of wanted. This feels a little cryptic. I was like, some of you might ask, how did you know which one of these you have to call and all that, right? This sort of like gets into a whole topic of how you can query elements from a Revit model. I've created a couple of videos about all of this. So if you go to the Pyrevit wiki and go under developer docs, and the first part of that sort of like page, you'll see that there are lots of videos about how you can actually use Python inside a Revit environment. There are a couple of things about the basics, and then the Revit Python shell, Revit Python wrapper, that kind of stuff, sort of like just to get your environment set up. But one of the videos is about collecting, actually the next series of videos is about 4 different operations that you can do in a Revit model. You can create things, you can read things, you can change things, and you can delete things, right? These 4 operations. We start with reading first. So this is about like how you can actually collect data from a Revit model. And then it sort of like explains why Revit model is treated as like a database. And then you can update and change values and sort of like filter elements and all that. So there's a whole lot of videos that you can actually watch about this. And then these ones that are orange is more about UI, how you can actually create good windows and interfaces and all that for your tools. So just bear that in mind that these videos are actually available to you. And then to find any of these, if you go into sort of like API docs and say filter the element collector class, then you'll very easily see that it's got some methods in here. And one of the patterns that you kind of see here is that I create this and I call a method on it. This is sort of like the chain of the events, the methods that I'm calling. Look at the off category, it returns the same data structure type as what that class is, right? So every time you call a method on it, it kind of changes itself and returns itself. So as you call method on it, you would fine-tune the parameters of this filter, and it would give you the stuff that you actually need. So I'm going to copy that because we wrote it once. I'm going to put it right here. And what we need is for all these API in Revit APIs to actually work, what we need is a handle or a reference to the document that's actually open, right? These are the stuff that you can actually get from Pyrevit very easily. So Pyrevit is also a module when you're writing your scripts, right? So if I go here, close all of these windows, and open one of these tools as an example. One of the nice things about having all these tools at your disposal is that you can actually start looking at how these scripts work and sort of like grab ideas about how to use APIs and make changes and all that right from here. If you hold Alt on your keyboard and click on any of these tools, let's pick something that's fairly simple. Let's go to List Elements. I'm going to hold Alt and click on List Elements. It doesn't actually run the tool. It'll open an Explorer window and points to the location of that button in the directory structure of Pyrevit. So this is what you see, just like what we created. Let me actually make it slightly wider. You can see that there's a Pyrevit core extension. There's a tab inside of it that's called Pyrevit that we see right there. The panel is called Pyrevit. That's the panel it's called Pyrevit in the corner, the first one. And then there's a stack of tools, these 3. And then there's a pull down, and there's a list element, all that. So eventually we get to this list document, list elements in here. That's a push button that a bundle that we have created, and there's a script inside of it that's sort of like right there. I can open that script, and I can see that the Pyrevit is actually a module that I'm importing a whole lot of stuff from it. So I'm going to grab that line. You can use this instead of importing Autodesk.Revit.db directly. You can just import all of those from the Pyrevit module. I get that access to the Revit handle, to the DB, and to the UI. So this DB namespace gives me access to database operations, and the UI will give me access to the UI, anything that's related to Revit UI. and I can use Revit. I believe it's active. Revit.doc is the handle to the document, right? So instead of just saying doc, you can get access to the active document from that Revit object that we imported from Pyrevit. And then let's go over a loop for W in walls, print W. Great, and you notice that when I saved my script, this script got reformatted. This is one of the things that, as a Python developer, it's a good sort of like habit to get into. In VS Code, you can actually set up what we call a code formatter as your formatting option. I'm using Black. That's a module that sort of like formats the Python code for you. This guarantees that your Python code, your complex Python codes, always look sort of like the same and organized between these lines and stuff like that, easier to read. So we modified our script a little bit. I'll close that one. So we collected the walls using a DB filtered element collector, specified the wall as the category, and converted all of this to elements, and then we just print the list of the walls, right? So I'm going to go to Python Cafe here. Notice that I don't have to close Revit. This sort of like, if you remember external references in AutoCAD, that's what that button really is. It holds a reference to this script on your hard drive. Every time you click on it, you'll run the script. So if you change it, the next time you run it, you'll run the updated version of that script. This is really important in sort of like development and exploration, is because a lot of times you're actually working on a project, like when you get into like large companies, large projects. I had projects that took me half an hour to open, like multiple gigabytes of file, gigabyte Revit file size, and it's really hard to open that model. So it's not very efficient to have to close Revit, open it again, to try to test whether this new script that you wrote actually works or not. A lot of times you write something and maybe there's a bug in it and it doesn't actually work and all that. So it'd be a lot easier to actually see that. Let's actually do that here. Let's create something that's invalid Python code. There's a missing parentheses over there. When I click on this, I'll get a traceback that, hey, like unexpected token, you needed to do this. So I could do mistakes in my script and not have any problems exploring, and sort of like don't have to close Revit at all. So let's click on that button again, and I see that I get a list of walls. But what I get also is the series of wall types. So in Revit, in my Revit model, I do have 4 walls listed there, but I also do have, under families and walls, a couple of different wall types defined, right? Stack walls are slightly different. So I do have a couple of wall types defined also. Now, the filter collector, the filtered element collector, will let you filter out whatever that's not sort of like the types, right? So there's a method on it that says where element is not element type. So I'm going to use that in my script. And before I call 2 elements, I'm going to put that right there. So collect all the elements in Revit, give me the walls only, make sure they're not wall types, and then convert them to elements so I can actually use them in my script, right? Let's click on that again. I get a different window, and this time we don't have the wall types anymore. So now that I know what kind of data that I'm collecting and the data is correct, I can actually run some queries on my data, right? So let's do parameter equals wall, the lookup parameter unconnected, right? And then I know that these are sort of like, let's do heights in here and create a list. And heights dot append parameter. I need its value as a double, as a sort of like a floating point number, as a like whatever the length is, like 20 point something. So I'm going to loop over the walls, get the height parameter, read its value, and add it to the list of heights that I have. And then I'm going to print. I'm going to print format a string that I can format, so I can say max height equals the format, and I'm going to use a Python function. It's called max. That sort of like gets a max of a series of numbers. I'm going to put that height in the middle. So I'm going to grab the max of the heights, format it, and place it inside this string and print that out. Very easily, if I click on this, I should get the max height of 20, whatever that unit is. So in this case, it's feet. So let's actually put feet in front of it. And if I go to my Revit model now and start messing with these heights here, I don't have to make changes to my script anymore. That script works every time I run this. So let's say I can run a script that actually collects stuff, right? Let's say I want to count the number of parkings that is in my view. I can actually query the Revit document, find all the family instances of the parking family that I have, the type that I have, and start listing those as sort of like parkings and start counting them and do analysis on them and all of that. So that sort of like is very similar to the tools that sort of like we have created over here. Like there's an inspect tool that counts the, actually let's say analyze, get parking count in current view. It's what I will just talk about. You can all click on this and it will take you to the folder that script is in. You can open that script inside your code editor and take a look at how that script is actually collecting parking. So it's using a DB filter collector on the Revit document on a very specific view, so on that current view, and it's looking for the category, a built-in category that's called OSD parking. It's making sure that it's not collecting parking types. It's just wants the parking instances, and element ID, and does a parking count on a list of parkings, and it does some extra analysis on sort of like on the parkings to be able to list them by type and say, hey, you got 3 handicap and 2 different types and all of that. So that's sort of like what Pyrevit will bring for you. You can create these Python scripts and place them inside your extension, create tools like this, and sort of like run them from your Revit instance that you have, and share these tools with everybody else in your company. You can place this directory that we just created on it, maybe in a shared drive, or sync it using a cloud file sharing platform that you have, that kind of stuff. So everybody has a most recent copy of it, and sort of like share it between everybody, and everybody can use all these tools across your company. The Pyrevit sort of like as a platform will provide a whole lot of other really handy tools for you, and I'll show you some of this stuff. Let's go to the Pyrevit documentation here, the wiki, and I'm going to show you a couple of different things that are actually very useful. So under reference, there is a section under bundles. If you click on Pyrevit bundles, this is all the information that you need about various different bundle types that Pyrevit supports. Push button is the one that we just used. Inside a push button bundle, you can put a Python script, you can put a C# script, you can put a Dynamo definition instead of a Python script. Whenever you click on it, it'll run Dynamo definition. If you have Rhino.Inside.Revit that I'll show you in a few minutes, you can put a Grasshopper script in there. There are these things that are called content bundles. You can put a Revit family inside of it, right? So let's say you want to create a tool for your colleagues to be able to place families in a Revit model. You can go here and say, actually, let me bundle tests. This is my test bundle. So test content bundle is a content bundle, and I'll show you what that is. If I hold click Alt and click on it, it'll take me to the directory. And inside of it, you see there's no script in here. There are a couple of Revit families, right? So what the content bundle does is that it just loads that family instance for you. So you can place these things very easily, right? So this, you can create something that's sort of like a family library in your Revit ribbon with a bunch of different families and different instances and all of that, and sort of like just click on them to place them. And you can see you can actually make that very specific to the Revit version that you're using. So these contents, these bundles actually do different things. You can have URL bundle if you want to click on somewhere and go to a website. UI bundles are the ones that we talked about, like tabs, panels that create UI elements for you, and a series of advanced bundles and all that. So there's documentation about all these bundles right here, and sort of like information about how you can actually configure those bundles a little bit more sort of like advanced. Like if you look at these bundles, you can actually see I've assigned colors to these buttons there. So if you want, you can sort of like mark things differently. Like there's an orange dot in front of this bundle that makes Revit put updated or new on the button. These are all options that are available for you when you're creating these bundles. So under developer docs, we talked about this bundle section, which is super handy, and everything else that's sort of like unread is related to that. The extensions talks about the extensions and all the information that you have for the extensions. I apologize. There are a couple of different things that are sort of like more advanced. Like you can have a startup script on your extension. So every time Pyrevit is loading, it actually runs that script automatically when Revit is loading, and it's loading that extension to maybe set up an environment, for your tools and stuff like that. There are these things that are called hooks. You can assign scripts to certain events in Revit. So every time somebody adds an element to the Revit model, you can configure it to run your script. Maybe you want to make sure that all the new Revit elements have a properly formatted value inside one of the parameters, right? So as you're modeling things, this script is filling these parameter values in the backend for you. That's what hooks does. You can hook up scripts to different Revit events. And then for your scripts, under the script section, you see all the utilities that are available to you when you are using creating scripts under Pyrevit in Python. I'm going to go use the effective input and effective input, output, and visualizing data to sort of like show you an example of these. If you go to effective input, you'll see that there is a big section here about a module that's called Pyrevit Forms, and it'll give you a whole lot of sort of like tools to be able to pop up dialogues like this to the user and ask for input. Like you can run a forms.alert, put a question in there, specify the buttons that you want to see at the bottom of that, and it will ask the user, and it automatically put the Pyrevit version right at the bottom. So if somebody sends you in a screenshot and say, "Hey, I'm seeing this error," you actually know what Revit or Pyrevit version they're running on. So different dialogues, pop-up dialogues like this. You can send a toast message, the one that sort of like pops out from the side of the window. You can ask for all these command options. So if you click on some of the Pyrevit buttons, you might have seen these. Like if I say pick, it'll show you a window like this, and you can sort of like use one of these options or start typing to filter down those options. These are fully available to you. It's called a command switch window, and sort of like you can use that, provide your options in here, put a message in there, and see which option user has selected. So a whole bunch of these are available. There's a warning bar that you can show to the user at the top of Revit window. You can do that. Opening files, opening windows. This is another really good thing. So there's a whole bunch of select windows in Pyrevit that you could use that you don't have to write yourself, right? So let's say you want to ask the user to select a series of views. You can just import forms from Pyrevit and say form, select views. Let's actually do that right here. I'm going to copy that, and I'm going to go to the script that we created. Now we can't walls in here, so really we don't have to do any of this, but I'm going to comment these out. I'm going to put my Pyrevit import right here with forms, and I'm going to say form select views, and let's grab the selected views and maybe print just a view object, right? So now in our tool, when I click on this, it'll pop up that window, shows me a list of views that are in my model. I can search for them. I can filter down maybe like 3D or something like that. It's got a whole bunch of filters to it, so you can use different filter types. All of these are pre-built in for you. And then I'm going to select these two and say select, and it will return the two views to me. So these are great utilities to make your scripts more sort of like configurable. And you can ask for different things, decisions to sort of like be made by the user. Some of these images are apparently not loading. Selecting title blocks, selecting element parameters. So I can use the same thing. Let's use that one. And so let's just call this selected. We don't have to change it every time. And now if I have two of these elements selected, when I run my script, it'll show me a list of, oh, this one argument. What did I do? Oh, I don't have Pyrevit open. Anyway, I'm missing something in here. But basically, all of this will sort of like are available to you. Let's see if I can go. I'll actually show you the Pyrevit source code at the end. So a whole lot of these are actually available to you as sort of like input. Let's say you want to select an image, select a color, select some values, select some unique values, that kind of stuff. There's a whole lot of these. That's under effective input. And you have a similar situation with effective output. So the whole lot of the utilities are available to you if you want to print outputs. You can put emojis in the output window. You can put sort of like selectable elements in the output window. So when you actually select those, let me actually do this with the wall example that we did. I'm going to go back to the walls. And we're going to go print our walls again. But instead, this time I'm going to say by the element, and then I'm going to, from the documentation, I'm going to grab the script and handle to the output. So this get output gives me a handle to the output window, and I can ask it to linkify a Revit wall for me in here. So if I click on this, I actually don't have anything selected. Select these two walls, or actually, yeah, all the walls can be listed just like this. And then I can click on these, and it would select that wall for me inside the Revit window, and it would mark that as sort of like clicked on, right? So a whole lot of utilities just like this that makes it very, very handy to be able to work with Revit documents. You can create tables, all sorts of stuff. And then you can also sort of like create visualize data. So I've put a charts engine inside of Pyrevit that you could import. You could create charts like line chart, bar chart, bubble chart, that kind of stuff. And this sort of like explains to you how you can actually set up your data and the columns and tabs in the data and create charts like this inside Revit window. So I'm going to go under Pyrevit in one of my tests, and I'm going to run a charts test here just to show you how these will work. See, this output window is sort of like a browser, and you have charts, and you can actually click on these and hover on them and sort of like see what's going on. So you can actually collect some data and print some decent charts in the output window that way. So that's that. I feel like that's as much as I kind of wanted to share about Pyrevit without getting too much into details. There's a whole lot of information about how Pyrevit works internally. You can put a web server on top of Revit in Pyrevit that you can have a instance of Revit running, and it can make calls to it to do stuff for you. There's lots and lots of information in these articles in here. Another thing that I kind of wanted to show you, I don't know how much time do we have left, but I do wanted to show you a great project that Jaffe, Kike, Scott, and I are working at McNeil on. That's called Rhino.Inside.Revit. Think of it as a Python developer. Think of it sort of like as another option to automate things on top of Revit. I'm going to open an example for you that we have sort of like created. Let's see if I can actually find this. Yeah. Let's go to create. Yeah. Let's do this. Delete objects. Okay. Let's have an empty Revit model. Rhino.Inside.Revit is a plugin for Revit. So if you search for Rhino.Inside.Revit, it'll take you to this Rhino.Inside.Revit website that we have created. And from here, you can actually download Rhino.Inside.Revit and download the latest version of Rhino 7. If you have never worked with Rhino, Rhino is a 3D modeling, surface modeling application. Let me see which one I actually do have installed, Rhino 7. So it's an independent software that's been out there for 30-something years, and it's a great tool to sort of like start modeling surfaces, right? And this is great for modeling like industrial design, all that kind of stuff, very accurate mathematically for surfaces. What it means is that Rhino has a great geometry engine that you can actually use. There's another tool on top of Rhino that's called Grasshopper that a lot of you might be familiar with. You might have seen something like this if you have worked with Dynamo on top of Revit. This is sort of like an environment that you can create, sort of like automate things using a visual scripting environment. So I can create a sphere in here, and I can put a value in its radius, and as I change the value, the sphere changes, right? It's incredibly fast and powerful, and has a huge ecosystem of plugins that people have been creating and working on it for the past 15-something years. What we have done at McNeil is that we've kind of brought that inside of Revit. So when you install Rhino inside, install it on Revit, it will give you this extra tab in here, and you have a button for Rhino in here. So if I click on this, it'll actually start loading Rhino inside of Revit. What that means is that you will have access to everything that Rhino does while working inside of Revit, and also Grasshopper on top of that. So I'll show you an example of this. Takes a little while to load. And that's a free add-in as long as you do have a license of Rhino that you could use, right? And you can get a student license if you want to. So I opened Grasshopper from the ribbon. So this Grasshopper is actually running inside of Revit now, right? I'm going to also open my Rhino in here. So if I click on the window and I click on Rhino, so you got Grasshopper and you got Rhino. If I click on Rhino, this is the Rhino that I just showed you, but it's actually running inside of Revit. Like these two aren't two separate applications. They're two windows to the same application, kind of. Think of it that way. And I'm going to open a model that we had. I created a very simple, tiny, ridiculous topography, let's say. It's very 8-bit, pixelated. But I'm going to bring that inside of Revit. This is a different geometry that maybe I received from somebody else, right? And I'm going to place some tags over it. I don't have to keep Rhino open. I can just close the window, but it doesn't close Rhino, it just hides it. I'm going to go to Grasshopper, and I'm going to open one of the scripts that we had. And notice that I have a couple of components on this. This is what they're called inside of Grasshopper terminology, right? Each one of them is a component. This is the one that grabs that mesh from the Rhino model that we had. We have created a whole lot of components very specific to Revit. Like if you want to add a ceiling, add a floor, add a roof, work with elements, work with documents, work with families, creating different filters. There's stuff that I just showed you with the DB, the filtered element collector. There are components for all of this. So you can actually visually configure all of this and sort of like figure out what you want to do. And I'll show an example of that. But you have a whole lot of components, over 300 components just for Revit. I'm using one of them that creates a topography from a mesh. So this, and you can see it's black because it ran a successful transaction in Revit. And you can see this pinned geometry in here. That's the one that came inside of Revit from Rhino using Grasshopper. And if I click on this, you'll see that the category is correct. It's topography. It is a native Revit model, right? And then what I do is that I create a Python component. So inside of Grasshopper, under math, you'll have access to scripting components. So you can throw a Python in here and create the different types of inputs that you want and name them whatever you want them to be. And create the outputs that you need in your script. And sort of like then double click on it and start modifying the script to make it run, right? Do whatever you want to do. In this example, what I'm doing is that I want to create a set of spot elevations on top of this topography. You don't have to pay attention to all of this stuff that I've selected. This is mostly like boilerplate template code. that I just paste on top of my script, so I know that I have some functions available to me that I use most often. But basically, this is the bulk of the script. I check whether that topo, that input here, is of type DB architecture topography surface, which is what the type of topography is in Revit's Revit's API. And then I call get points on it to get all the points, and I convert the Revit points to Rhino points in here, and I output them at the output window parameter. So that means that Grasshopper can show me all these points of this topography right here, right? And then I use another Python script to actually do something. So let's go create a annotate spot elevation, spot coordinate. I'm going to put this somewhere here. And then I'm going to select that. And the Grasshopper will run. And at every intersection of those points, we'll put a new spot elevation. And you can see like the bottom is 0, 0. But as you move up, you can see the values are changing because it's reading the right elevation from that topography. The shape of the topography is exactly what we brought it from Rhino. The way I'm doing this is that I kind of figured out a way. I couldn't find a way to actually create a decent tag inside of Revit. So what I decided to do is to create one and copy it around. So I used another script. Again, the top part of this is all boilerplate code. All we're doing is right here. We check to make sure that this element is the spot dimension, and then we run a transaction in Revit. And most of these lines are actually handling that transaction. What we actually do is here. We use the element transform utils to copy an element from one location to another location and sort of set that to the new elements that we add. So we basically automate the process of copying this tag into the various different locations based on the points that I just found out from there. So that's a great example of how you can actually use Python with different APIs. In this case, it would be Revit API, Grasshopper API, Rhino API. All of these are accessible to you inside the same environment. And you could automate things the way, your projects and all that. Another simple example would be just as a collector. So if I want to query something, I can put the query rooms by number, let's say. Open this Revit model. And I have a series of rooms in this Revit model. And let's say I just want to find one of them. I want to show you how you can create queries in Grasshopper, right? So we have a component that you can select those built-in parameters or categories from. And in this case, you notice that Revit has a lot of built-in number parameters, but they're numbers of different things, right? They're numbers of rooms, spacings, let's say, I don't know, number of repeating detail number. There are a lot of things in Revit that has a parameter that's called a number. What we're looking for is a room number. We sort of like set that, create a rule in here. And this is fairly complex to do inside a code, but it's fairly easy to do in a visual scripting environment just like this. I want to create a rule for whenever that parameter, the room number, equals 106, the value. And then I create a filter with that rule, and then I find all the elements that pass that filter, which ideally should only be one. There should be only one room that's numbered 106. And if I go around and sort of like take a look at this room is called 106. But what if I change another one to 106 too? Revit complains, and then I'll get 2 rooms here. So maybe that's a tool to find all the duplicate Revit numbers or something like that, right? So this also gives you the ability to filter everything else that you want to do inside of Revit. So all these filters are available to you right in here. And then in terms of sort of like automating automating geometry creation, just a very, very simple example, because I don't think we have a whole lot of time left. I'm going to go to Rhino.Inside, Rhino. Let's use a new model. Let's say large objects. I'm going to draw a line in here. I'm going to use a curve parameter to select that line. And then I'm gonna put a wall component. See that wall component is one of the stuff that we have created for Revit. Sorry. Add wall based on a curve. And then I pass the curve into this, and Sunday, and that curve was tiny. Sunday, I have a whole wall showing up in red. Why did it happen? Because we actually created a wall inside of Revit automatically. So if I go now, I'll close that, we'll move it down. If I go here and grab the end of this and change it, see that the wall inside of Revit actually changed too. And this is all because the grasshopper component right here is actually running and driving all these changes. So this is also a very, very powerful, great environment to do automation inside of your projects. You can actually explore very, very complex geometries using Grasshopper and Rhino, very complex meshes of sort of like surfaces, let's say an envelope of a building or like interior design, very curvy, complex surfaces inside of Grasshopper and sort of like bring that into your Revit projects this way. I feel like this is most of the stuff that I had for today. If anybody has questions about this, I'm here.
Can you hear us? Okay.
I can hear you, but the volume is very low, and I don't have your video feed anymore. Oh yeah, now it's back.
First of all, thank you. It's a very nice presentation. Since I'm a first semester student, this was a lot of information, and you lost me a bit on the way, but it was very interesting and definitely something I need to look into, especially this Grasshopper and Rhino.
Yeah.
But yeah, it was a little bit too fast and too much information for me. But it definitely seemed like something I have to look into, and especially the Pyrevit also.
Oh yeah. So I get this quite a lot, that sometimes I speak too fast because I feel like there's a whole lot that I want to share in a very, very short time. But if you missed any of these, the Rhino Inside has a great page in here. Everything that I talked about is documented in the Getting Started and the guides, and we have plenty of videos under Discover if you want to start sort of like looking at what options are available with Rhino.Inside.Revit. And with Pyrevit, that wiki that I showed you, the developer docs and these videos, everything that I talked about is actually on the videos there too.
Yeah, so let's go through them. But yeah, it was a little too fast, and always had to do it on our computer also. So when we looked down and tried to click on the stuff you did, then looked up and you were 2-3 clicks ahead, and just was too fast. But yeah, I'm gonna go through and look all of these videos through.
Sweet.
Yeah, maybe put the websites in the Teams channel.
Maybe we can. Yeah.
Okay, yeah. Oh, let me actually do here by the tabs. That's one, and then the Rhino Inside Revit is at the other one.
You guys also made the Rhino Inside Revit plugin?
Yeah, so this is most of the focus of Jaffe on the call and Kiki and Scott and McNeil are getting this Rhino Inside Revit to work. I kind of started on this, but I kind of got distracted with creating a Python scripting environment in the new Rhino that's coming out. So I'm a little bit distracted with that right now. But yeah, this is one of the things that we actually develop at McNeil as well. And the plugin is free as long as you have a licensed version of Rhino 7 on your machine. You could use the plugin to bring that inside Revit.
I have one question. In Grasshopper, on the window you are right now, all the small buttons you have up at like geometry and primitive and input, stuff like that, did you program all those?
So yeah, so Grasshopper has been around for the past 15 years. So everything that pretty much all the stuff that you've seen here have been created by a guy that we have that sort of like created Grasshopper, David Rutten at McNeil, that sort of like created all of this, right? What Rhino Inside Revit does is that it brings everything that's sort of like Revit based to this panel. So Kike and Jaffe and I are the ones that actually created all of this, plus the parameters for Revit that are listed here.
Okay. Is there can you in some way like click on the button and see the script that you've made to import these things, or
Like in Pyrevit?
Not in
no, just in
Grasshopper.
this window right here?
Yeah, not in Grasshopper. Grasshopper is a what we call a compiled application. So the source code is in Python, right? But all of these buttons and everything else that you can see here are available. The source code is available if you go to the Rhino.Inside.Revit website and click on this GitHub at the corner. You can see the source code right here. So if you're familiar with C#, you can actually get inside the source and see the source code for all of these components right there.
Sorry, we just lost the internet, but we're back now. Can you hear us?
Yeah, I can hear you. Can you hear me?
Yeah, sorry, we just, from where I asked the question, we didn't hear anything. There was
Okay.
Yeah.
Okay, so I was saying that Grasshopper is a compile application, so it's not easy to see the source code for all of this. But because it's an open source and free application, if you go to Rhino.Inside.Revit wiki and click on this GitHub link at the corner, it'll take you to the source code for the whole project, right? So if you're familiar with C#, you can actually look inside of this and look inside Rhino.Inside.Revit.gh and look at the components and see all these components that you see here and here. The source code for them are available on this repository. You can actually, if you know C#, you can actually get involved and contribute to the project too.
This is for the Pyrevit, the extension that you added. Magic effect. If you change the file path, now you save it to the desktop, but let's say you move it to Documents in the File Explorer, will you have to go back into Pyrevit and update the file path?
Yeah, you have to change that. Yeah. So I would close Revit. I would change the path, close Revit, open it again, and it would load it from a different location now.
Okay, so it updates it automatically, actually. So
Yeah, so as long as you change the path, you don't have to change anything inside that extension. You just move it somewhere else and put the new path in here, and it will load it from that location.
Okay, because I thought you had to remove it and then add it again as a new file.
So let's actually do it. No, let's see if we want to move that extension somewhere else, right? Let me create a different directory here. Or actually, let's move it somewhere on the documents. Let's grab that extension and put it under maybe downloads. Let's put it here, right? And I'm gonna paste that here. Windows. Oh, I got the scripts open. Okay, so I just moved the whole extension, right? It doesn't do anything to my Revit. If I click on these buttons, they don't work anymore, right? Because they're not there. But I'm going to add the folder to the downloads and remove this one. I'm going to hit save. And then I can, because I already have one there, I'll just close Revit and open Revit again. So it doesn't duplicate the Revit that I had. But you only have to do this once. Like this is not something that you do like multiple times a day, right? You just pick a location, let it load. And when you install Pyrevit by default, you should see that this window pop up when you sort of like launch Revit with Pyrevit installed. If you want to turn it off, the second window shouldn't show up on yours. That's a development test that I have. You should see that window. And then it goes away after a while. But if you don't want to see it, you can go on the Pyrevit, Settings, and then under the reporting level, you can say no reporting. So it just doesn't show any window, opens Revit. And then you'll see that Python Cafe, the tool that we created right there.
Maybe I have a question. This is about Rhino. Maybe Jeff, Jeff, you can answer this. when will you like suggest that we should start looking into Rhino? Because it's not something I've heard about while studying here. Mostly that I've heard about the Rhino and Grasshopper is actually from LinkedIn, where I've seen a lot of people from the industry using it.
Yeah, Rhino doesn't have like a massive sales or marketing, so that like you're going to hear about it from users typically, and so we try to be user driven, and then one thing we do offer is a 90-day trial, which is pretty substantial, and we'll get you through one class. There's also a student license that we make available. It's going to be as cheap as possible. That a lot of architectural schools will put it in about their third year, where they start doing more really parametric, wavy type shapes, learning Grasshopper. But Rhino itself is like, it's a Swiss Army knife. There's so many tools. A lot of people use it for just transferring. It'll import something like 40 different file types. So it's really a utility in all sorts of industries and all sorts of phases of architecture, from schematic to fabrication. So it's a really every architecture firm nowadays has at least a few Rhino users and Grasshopper users. So I think it's well worth kind of spending your personal time, if you need to kind of dive into it a little bit. So.
Sure. Do you have any questions? I think that's it for questions. Yeah.
Sweet.
Yeah.
Well, I hope this was useful for you. I'm sorry that I went through too many things really quickly. But I hope it's been useful.
I think actually we're probably going to be using